So I'm putting this in an airport lobby. Apologies for any background noise. I'm going to talk through this as quickly as I can. So the first request today was problem 6 on the review, so it's this piecewise Laplace problem. Our approach is going to require taking Laplace of that piecewise part, so we're going to need to convert that to something that uses the step function like we're used to taking Laplace of. So we're going to use that u of t minus 1 since there's a discontinuity at t equals 1.
Attention Air Canada passengers, flight 544 from Kelowna, Vancouver is now boarding all zones here at gate number 11.
And then it's actually going to be
Your
just u
ticket
of t
confirmed,
minus
please
1
make your way over to gate 11 immediately for boarding. Mahalo.
minus 1. And here I'm kind of showing you why that works. When we plug in 0, the u is 0, so we just get that minus 1 that it starts at. And then if we plug in a higher value of t after 1, I think I'm going to do u of 1.5, yeah, then that's going to give 1 to the first part, subtracts the 1, and we end up at 0 that we want after t equals 1. So this function seems to work. If you all need to use that like plugging in f and g example that I wrote for you, that's okay. Just get the hang of it before the exam. And then after that, we can go ahead and take Laplace of both sides. This is how you're going to fill in the first entries on the web work. So taking L of y prime plus y, we use that linearity to break it up. We plug in our property for the Laplace of a derivative to be s big Y minus y of 0. And then L of y just becomes big Y. And then we have to plug in what our y of 0 is. For my problem, it was 3, so I plugged that in. And then here I'm just simplifying it a little bit because I know I'm going to solve for big Y eventually. Then taking Laplace of the right side, I'm going to take Laplace of that u of t minus 1 minus 1. So I do have to use my Laplace sheet. Remember, you have those formulas on the exam. Just get used to looking in the right place for them. I'm going to need, I wanted to break it up for linearity first. So just those two different parts. And to take Laplace of that left term, we're going to do that e to minus 1s because we're doing t minus 1. And then we do Laplace of whatever function it's multiplied by. In this case, that's 1, so we just do 1 over s. And then subtracting L of 1, we just take away 1 over s. So the first two things I calculated are what go in the first two boxes of your web work. And then we proceed with trying to solve for big Y in terms of s so that we can eventually take the inverse Laplace and get our solution. So I set those two terms equal, and I'm solving for big Y. It's just an algebra problem at this point, and I think big Y is also one of your web work boxes, so you could go ahead and put this in right now. I'm going to start to simplify it a little bit just because I know that I'm going to need a partial fraction decomposition, and I want to see how similar they are. So I do have this repeating 1 over s plus 1, so I'm only going to have to decompose one fraction. I think I'm about to do that. Yeah, what I'm going to do is I'm going to take a over s plus b over s plus 1, and I want that to be equal to 1 over s times s plus 1. I wrote that down wrong just now, sorry. But we have a times s plus 1 plus b times s should be equals 1. I separate the s and the not s terms. On the right side, I have 1 and then 0 times s. So that's going to tell me that a needs to be 1 because it's the thing that's not multiplied by s. And then a plus b has to be 0 because there's no s on the right side, which means b is minus 1. So I'm going to decompose that product into 1 over s minus 1 over s plus 1. If you run into issues here, make sure you're distributing that minus correctly when you start applying it in all the different terms. So my big Y was given by this thing that I'm copying out again because I'm on a new slide, and I forget very easily what things are supposed to be. And I've just plugged in those decomposed fractions. That middle term is where I expect some of you all are going to run into minus issues, so just be careful. And I'm actually going to really carefully multiply all that out because I tend to make that kind of mistake. So I've got my minus 1 over s plus my plus 1 over s plus 1. And you could combine those two s plus 1 terms at this point, but I didn't. This is going to be that big Y equals box in your web work. Sorry, I just nudged the screen. And so now we find the last box, little y, our solution, by taking the inverse Laplace of that whole thing on the right-hand side. And I'm going to have to use the inverse Laplace of that f of t minus a, u of t minus a property here. So I'm going to get 1, and I would evaluate it at t minus 1, multiplied by u of t minus 1. The 1 is the same everywhere, so I actually don't have to worry about it. It's just going to be u of t minus 1. And then here I'm going to get the inverse Laplace of 1 over s plus 1 is e to minus t, but I'm going to plug in that minus t minus 1. And again, make sure you're distributing that minus sign to the whole t minus 1 here. Like, don't do minus t minus 1. It will be minus t plus 1, or written in parentheses like I did. Inverse Laplace of 1 minus s was 1. Inverse Laplace of 1 over s plus 1 was e to minus t. And again, 3 times e to minus t. You could put this answer in right now. I'm going to go ahead and simplify it a little bit more just because this is how I like to see my answers. Not from you all on an exam. Stop without simplifying on an exam. Just when I'm working through it, this is the form I want it to look at. And then real quick, I think I'm done with the problem, but I do want to highlight, if you're getting that last part wrong, make sure you're plugging in e to like minus t minus 1. First of all, make sure you're including that t minus a, and then once you have, make sure you're applying the argument of the exponent. In my case, it's minus 1, but for you, it might be a different number. Make sure you're applying that to the t minus 1 or t minus a that you have. In this section, I think it's almost always going to be missing like double negatives that throw you all off. So